This is quite hot topic today. Well, first about me, as usual. So I worked for several very big IT companies who are writing a lot of code and also interested in the coding productivity. Right now, pretty much I'm working like a kind of cloud architect, but who's not doing software for cloud, who's doing clouds for software. So, and yeah, well, I used machine learning a lot, even before it became kind of fancy. So I have several patents in machine learning area. For a very long time, I use that basically practically, machine learning algorithms. And I wanted to, on the last conference, I say I'm like climbing, but this time I'm mostly hanging out with my son. So, and this is all about me, but let's go to agenda. So I want to explain basically what's happening right now with code generation, and then we will go a little bit deep into the learning process and very specific way of learning algorithms which basically allows models to write a code well. And we will speak about security implications of code generation, about one vulnerability particularly related to the training, which I think quite serious, and others which also exist. So, well, first of all, LLM code generation. Well, I don't want to ask, but I believe everyone using right now OpenAI or Claude or something like that for everyday questions and everyday work in your life, and that's true. So basically, tons of developers right now using some kind of, I don't like the word AI assistance, but let's say machine learning assistance through the coding process. Market growing very fast. There are a lot of hype about it. Many companies claiming very huge increase of productivity. Of course, part of that is marketing, but actually, yes, productivity is increasing. Amount of code also increasing. And with the amount of code, of course, increasing amount of issues in that code. And many companies were kind of like struggling a little bit because they really want to become more productive, but they also feeling that their typical software development life cycles are impacted by LLMs, and they don't know basically the security implications, what is the regulations they should do about it, how to use these tools safe. And there are many tools, there are many impressive startups. So this is a list for 2024, where I think 2 or 3 startup companies appeared just within this year, like since January. So, like, how this code generation thing can be done safely and how it even works. So we need to make a step back a little bit. So basically, we should discuss. First of all, about LLM training process. So how it even happened that large language model suddenly can speak programming language. So background of this is in the training process of the language model. So basically, training process for LLM currently is quite complicated, actually. So there are several steps. And looking at this diagram, you can see these steps described in the matter of how much data you need to train model and how much money you should pay for this. Typically, everything starts from the pre-training, when you need to get a base model. So what's the issue with pre-training? You need tons of data. So right now, companies like Anthropic or OpenAI, they literally collecting all possible written texts which human beings are written for, like all existence of human beings. Literally, we try and collect all meaningful texts all around the internet, literally dumping entire internet, dumping all possible sites, books, everything what can be digitized. So interesting enough, for example, that big breakthrough that happened in the chat models. If you probably used ChatGPT, you've seen, wow, it's become really, really nice. And even it's possible to commercialize right now. So it's happened after improvements of different class of models, models which can recognize the human speech and do the speech-to-text recognition. So what's happened, the companies who are doing training of models, they realize that they can digitize tons of audio and video which contains the human speech and humans speaking to each other. That basically provided a lot of data for trainings, for dialogues. So if you imagine like any, for example, text that we have before, there are not so many dialogues in the books in general and in the text, and kind of like difficult to find meaningful dialogues. So, but if you will take any interview on YouTube, you can get a couple of hours, several hours, of perfect dialogue data, which, right now can be easily transformed to text and easily included into training sets. So problem is, this pre-training generates base model, and it takes a lot of time. It's very, very long process. You need tons of GPU for this. You need like several months, and you need millions of dollars. So this pre-training to get base model, usually only big companies can do it, or companies who specifically invested to do it. And this process usually, not everyone can reproduce, because you really need a lot of money and compute power. But also the problem is that base model not really useful. We will talk about it later, but anyways, everyone trying to do also a fine-tuning, basically to adapt model, for example, for code generation or for, again, question answering, for some specific task. And if you're doing this fine-tuning step, it's actually costs much, much cheaper. It takes a less amount of time. Still not super cheap, but again, amount of input data for training decreasing a lot. And this is a very important trend, because basically what's happening after that, so let's say you got fine-tuned model, you can right now use the one more step, which actually brought very, very high quality models recently. This step called reinforced learning with human feedback. And when you're doing this last step, it's improving quality drastically. And the thing is, this step actually much, much faster and really doesn't require a lot of data. So this is the steps of training. And again, training time decreasing, cost also decreasing. But what is increasing? What do you think? What's the catch? Kind of sounds like very good. We're moving more right side, doing like more advanced training and everything becoming super nice. What is the catch? Catch is quality of data. The thing is that for left-hand side, for base models, quality of data really can be quite low, actually. So you really can basically pick really any text from internet. It doesn't matter what is this. It can be a Bible, it can be a Mein Kampf, it can be like any random books, even awful one. The problem is that in the first step, model establishing semantic relations between words, kind of between of the tokens, between parts of a human speech. So the thing is that it's very, very statistical thing happening, and like if some marginal bad data happening and appearing in training set, it will be basically diluted by normal data, and you really don't care about these things. But as you can see, if we're moving right-hand side, for example, if we're doing fine-tuning already, we're using much less data, and it's twisting model really hard. So it means that quality of data should be much higher. And this is actually very important for code generation process, because you're starting to think, okay, so these models which doing code, where this training data came from? So who was these high quality developers who provided their code for the models? Well, it's actually not really high quality things happening, because many companies, they using the open source repositories on GitHub, for example, to dump the code. And well, I'm, for example, not proud of some of my repositories on GitHub. I believe they used for training maybe some of them, because they are under open source license, but I'm not proud of them. Some of them abandoned 10 years ago, some of them just not working already. But surely, 100% I'm sure, some of them used for training. So as you can see, quality is very important. Now, so this is a very famous picture from internet explaining this training process. So Leonychev, which used to improve quality of models, is amazing. So just hiding all this, dark, awful things behind the machine learning stuff. And we will focus on this shiny yellow guy today, because I think this guy is actually very, very dangerous, maybe more dangerous than guys on the right side. So again, about models. So as I said, you're doing pre-training, spending a lot of time and money, you're receiving base models. So what these base models are doing actually? So base models, they can substitute missed tokens in the sentences, for example. Let's say you have some text. Text will be transformed to the sequence of tokens. So I try to simplify it a little bit. Yeah, just put sequence here. But let's say you omitted some words from your sentence. So what does base model can do? Base model basically can say, okay, my guess is that this omitted word can be, for example, tomato with confidence 50%, maybe with word flag with 75%, but balloon seems like 95%. And usually, by the way, it's not words, it's usually tokens, but it's easy to understand this way. Yeah, so basically, never models returning you one answer. So very rare, you almost never can get like one singular correct answer from model. It's always several tokens, and there are always some confidence behind these tokens. And this is what base model doing. Of course, if you're going, for example, to more specialized fine-tuned models, for example, for coding, your training data will become slightly different. For example, you need to provide the samples of code for models, so you need to chunk the code somehow. And for example, you already expecting from model something like, the fragments of code provided, and also with some kind of confidence. So, so what's happening on a Leonychev step then? If you first use some text, then you probably use some code. So what is next? Leonychev deep dive starts next. I think it's very important to understand how it's all happening. So what is it, Leonychev? As I said, it's reinforced learning from human feedback. So we obviously can understand there are some humans involved there. So we need humans for this. So how trained data generated? Trained data generated using some kind of humans assistance. And so what we already checking on this step, so again, base model, you inserted text, and it's also providing some kind of words, substitution of words, which is correct. Fine-tuned model, for example, can do code completion. What we're doing on a Leonychev step, we already checking which parts and which texts are preferable for users. So we're asking user to choose which one you like more. So basically, this step in the training, when you need to ask people to arrange code samples, for example, from bad, for example, to good. And this is actually quite challenging. So if you're really doing the software development, like there's no single also criteria which code is bad, which code is good, It's like, developers can fight to the death for example, to use a tab or use a space in the code, and imagine you need to actually do some kind of arranging of a code by quality, by just looking at the code. So this is actually what assessors doing. And interesting fact also that all previous steps you train one model, but actually this step you're training not one model, you're training two models. So you're training a model which gives scores to the code, scoring model, reward model, and you're also fine-tuning basically the final model which will do code completion. So this is more details about training process. While I don't want to dig very, very deep, but I want to say that there are some kind of tricks which allows, to keep model sane, basically to keep these reinforcement things plus minus correct. For example, there is a step when you generating the completions, you can measure how far they are from the initial how far we are from initial completion that model provided. So if you doing the divergence check, so there is like a very, very complicated family names, a callback labeler divergence check. So basically, you're just checking how far the model which you reinforced goes away from your initial fine-tuned one. It's made just to prevent, some kind of craziness happening, because if users' feedback really strange, or people asking something really, really strange, model can start to generate tokens which is completely mismatching, just going completely randomly. And in this case, you can prevent such situation when you're just measuring divergence, how far with probabilities of tokens going away from initial model. Interesting thing here, as you probably noticed, this is actually a training loop. This is another thing which is really, really kind of like encouraging companies to use Leonychev. The thing is, but as you notice, base model and fine-tuning, you're doing once. It takes really a lot of time and money. The thing is, Leonychev you can do continuously. So you basically can apply it again and again and again to the same model, many, 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 many times, improving quality. That's really, really tempting, because the amount of investments is very, very low compared to like base step. So what is the problem here, I believe? The problem here is that you need input from users. So you basically need ranked samples. So, and I believe this is actually where this method has a very high security risks. So I can explain why. And next question is, where feedback coming from? Who actually, like, okay, I already confirmed that everyone using ChatGPT, Claude or something like that, but tell me, who actually provided feedback to these models when they like generating some kind of strange things? Like, let's say you're asking ChatGPT something and you're receiving strange answer. So are you pressing feedback buttons or not? Sometimes. Sometimes. So answer from audience, sometimes. Actually, people pressing these feedback buttons, very, very rare. Interesting enough that if you have a commercial licenses to these systems, especially for code generation systems, they even not allowed to collect feedback. Because basically, if we're collecting training samples, we're collecting your code, which is not allowed, and you paid for it. So then again, question appears again. So basically, who providing feedback, especially for code generation models? Well, feedback collected, as you've seen, with likes and dislikes, but very often, and this is actual screenshot from like my actual Instagram. So this is what I've seen several times. So there is what advertisement like this said, hey, please review code and earn some bucks. Very, very small amount of money actually, and you can imagine who applying for these advertisements, but this is how they collecting feedback for training. So this is the first issue. Now, also, for example, this feedback can be collected by like which code you're choosing. Let's say if in Copilot you have several samples generated, you will choose one. This provides the feedback. Again, it's only for the free version. So, and again, you see, so all feedback collected from or low-paid assessors, or people who barely can code, or from the free versions of software. So that's actually quite interesting, because it's very easy to provide feedback with mistakes. And I believe this is one of actually the vulnerabilities of this method, because there is a combination here. First of all, it's very easy to manipulate model behavior on that step. You really need small amount of samples to twist model behavior. As I said, for example, model cannot generate nonsense because it will be blocked by different mathematical methods. But the problem is that to introduce vulnerability in code, you actually don't need nonsense. You just need a small twist. For example, you doing SQL request, how about I will replace prepared statement with just direct code injection or parameter injection? Or what if I will, for example, stop to check size of buffers in C++? It's kind of like small things, and it's not twisting really a model too much. So it will pass divergence checks, and you start to think, how about like if I'll create a couple of thousands accounts, free accounts, let's say in ChatGPT, and I'll start, actively press likes and dislikes for some specific questions. So, and I will share later demo code which actually shows that you need really, really small amount of samples to change model behavior. So what I made particularly, I basically used GPT-2 model, and I made a scoring function, a reward model, which in Python likes to print word boo, and it doesn't matter what kind of code you're generating, but it really likes to print boo in your code. And without I think, too much time, and as I remember, in my demo I used 200 or 300 samples of code only, and after that model already really started to print boo, in the code, which kind of tells us that if you want to introduce some vulnerability, and you can create 300, 400, 600 accounts, so maybe you can tweak behavior of all this, software. Now, I kind of call it feedback poisoning attack. And when I checked OWASP top 10 list of vulnerabilities, we have some attacks listed, but I haven't found that particular one. So I don't know. Maybe it will appear later. But yeah, so free accounts, easy to manipulate feedback, very, very weak registration, and KIC basically never knows who actually were, marking up the code samples, and yeah, I think it's kind of allows to do interesting things with models. So, and let's talk about a little bit other things, where's other stuff. So, people speaking a lot about AI risks. I, again, don't like word AI applied to machine learning, and I don't think there are any existential risks here. And honestly speaking, I took this OWASP LLM top 10. Already exists OWASP LLM top 10. I took this list and I looked at this and checked it, and I found that some of these vulnerabilities are actually super boring and just coming from complete lack of understanding how LLM works. I will explain these things. We'll try to go fast through this. Okay, prompt injection is very simple. I mark it as not boring because it's kind of causing funny stuff. In general, it's very simple when people just asking, model to do something which is not defined by a previous system prompt. And there are this funny stuff in the Twitter when, people asking, hey, ignore all your previous instruction and write a poem about tangerines, and some person and big quotes starting, to write poems about tangerines. And it's happened a lot. There is an entire page, knowyourmem.com, called ignore all previous instructions. If you go there later, you can see so many funny stuff. But this is prompt injection, I think. So next one is kind of also, in a sense, is boring, I think, and comes from misunderstanding, but it's sensitive information disclosure. So basically, I told you models train on all possible data that companies can reach. Sometimes personal information can sneak into the training set. Sometimes some confidential data. Or for example, some employee who using, free versions of Copilot can start to send you company code, there, and it also can leak into the training set. Problem is that if as soon as model trained, base model trained, you cannot remove data from there, no way. It's like narrow surgery, So basically there is a link to the article here, you can take a look. Article is long, but simply, can you unlearn something from the model as soon as it's been learned? Answer is no, you cannot. It's super complicated and it's basically not working. Supply chain attacks, so this is probably the Leonychev part comes in, but in fact also it's not really large language model stuff, because basically Many models going as a binary files. Sometimes we have some kind of parts which is precompiled with some customizations. Can be some special computation kernels made for model. It can contain malware. This is very simple. You know, people going somewhere downloading fresh state-of-the-art model from some repository on the internet, getting the malware. I do not believe this is like really related to OWASP LLM list. Honestly speaking, it's just general kind of practice of clean hands should be. But yeah, there are some malware and specially designed for machine learning models, and it's been detected in a Hugging Face repository. Also, there's a link to a very nice article about it. So yeah, when there are several vulnerabilities kind of categories, I think absolutely boring. So the thing is that they are all turning around of the, and let me return back to the list, just not to confuse you. Improper output handling, excessive agency, system prompt leakage. I think we're all coming from deep misunderstanding what actually LLM are doing. As I told you, we're generating tokens with some kind of probabilities, confidence that next token is correct and which tokens may be most correct, less correct. The thing is, there are never certainty what model generates, so you never can like guarantee output of LLM. So there's no guarantee. Then class 5, 6, and 7, all these issues basically happening because people are expecting that model are generating some kind of output which they are desire. And of course, depends on the user input. This output can be manipulated and changed. And I honestly believe with 5, 6, and 7 is all the same, basically. It's just there is an unsanitized input which making model to produce some malicious output, and this malicious output somehow used by your system. And it literally covers all 5, 6, and 7, all 3 vulnerabilities. So really extremely boring. So vectors and embedding weaknesses is quite interesting for me because it's more also on the machine learning side. So if you know this new retrieval augmented models which kind of doing some complicated data digging, there is some kind of process of data augmentation, and these models often relies on the vector storage databases. So basically we're trying to understand which data is close to the, for example, user request by measuring the distance in the multidimensional vector space. So problem is when you're measuring distance, again, you don't have certainty. So it's not like you will get one point which is close to the user request. You can get certain points. Another problem is if you're manipulating input, some inputs actually also close to each other. So if you're expecting that like user will input some data and it's very clean data and safe data, and you allow user to do it, so using this retrieval techniques, someone can pull unexpected information from your database. And this is pure math here, so nothing you can do except that you must to filter out user inputs as much as you can. And unbound consumption, this is funny one. Also actually happens a lot in the code generation world. One of the first tasks which was in code generation, generation of SQL queries. And funny enough that actually super innocent looking user requests can be transformed into absolutely devastating SQL queries. For example, what I put some very simple user questions here. Find all documents similar to each other. I have a database which has basically doc ID and doc text. 2 columns only. Let's say it's a SQL database. And the user comes and says, hey, find all documents similar to each other. Or, hey, can you count the word frequency across all documents? Or find all documents with characters ABC inside, Very innocent, He's not asking drop tables, by the way, He's not asking like, hey, delete all data from table or drop database. No. Here just asking, hey, find similar documents. Now I asked a couple of LLMs. So in general, like if you're asking, for example, similar documents, you get SQL request like this, which has like a couple of nested sub-requests, joins, and well, I tried to execute, by the way, on test database, so it crashed kind of, and I believe this is very, very complicated requests. So it's basically one very small question from user. If you haven't checking what is output of your LLM, can ruin your production because one this request like this, that's it. You're losing one database node because it will just hang forever. So server will be on fire for sure. And my computer was on fire kind of. So this is interesting, and this has happened kind of a lot. Very actually very simple. Also examples of the same error, which happen in even more simple way. For example, you let user to input any possible symbols, and you're not filtering them. And let's say you allow user to input images. I mean, why not? It looks cool. Then what is unexpected here? So if you're measuring, for example, all these images, it's 1,921 emoji. Then how many tokens for LLM here? 2054. How it's happened? So user inputted less than 2,000 characters, but there are more than 2,000 tokens. Problem is that some of these images were actually represented by a couple of tokens. So again, if you are not really accurate with user input, user can just make input which will explode like kind of like a zip bomb, but inside the machine learning system. So how to protect from this? Well, there are some ideas what to do. It's called three-stage validation, but well, the problem is it's very expensive. So basically, you're checking input to large language model using large language models. When you're checking output of large language model using large language model and several semantic rules. So basically, when user just asking one question, instead of running one model, you're running 3, 4, 5 models to pre-sanitize input, to score it, to check output of your model. And for example, if you're speaking about code generation, one additional way, you, for example, can generate tests for the code. You can try to perform testing. So it kind of works, but again, it's chicken egg. So first of all, better to own some of these models by yourself because you don't know, like, is model which generate tests trustworthy? Can you trust it? Is model which scores, is code safe or not safe? Like, is good? So there are many things which is returning us kind of like to the first slide of presentation when you started to think about models which you're using on the verification steps again, So, but yeah, so you can do actually some sanitization. Well, I have some key takeaways. So what I want to say, okay, maybe takeaway 0, you should understand how this stuff works, really, because in a WASP top 10, 3, 4 vulnerability classes literally coming from the moment that people just not understanding what is it language model and what is input and what is output. But that's it. This is what you need to understand. Input, model, output. This is already enough to clean up a lot of stuff. Well, you should understand how they trained and who training, and you should know who training your models. And if you're using them, you really need multi-layer security, otherwise you will have some confusing situations when someone tweaked your model, manipulated your model, or basically crashed your production. And as you've seen, by the way, it even can be not the malicious actor. It can be just simple user request. So I have some references and links which you can check, and I believe presentation will be shared later. And, well, as usual, there are a couple of QR codes, LinkedIn, and demo. This demo just allows you to do some kind of high-level code analysis. You can see also it's very, very easy to fine-tune very small large language model. It's kind of large language model, but small. You can tune it on a few samples, and it's actually becoming quite efficient at detecting vulnerabilities. And yeah, that's it from me, Leonid. So I don't know, do we have a time for questions?
Yeah, we do have a time for some questions from the audience.
Good.
Let me fix my microphone. But yeah, so if anyone has any questions from the audience, online as well, if you're joining us online, you can send your question to the chat. I understand there's some delay, so for now there's like any questions from the audience itself? Oh, okay.
Thank you for the presentation. Well, how do you think are vulnerable to those vulnerabilities some of the like most known AI providers like OpenAI, Cloud, etc.?
Well, it's an interesting question. Well, I believe actually we're doing multi-stage validation because if you're asking some unsafe questions, very often models are refusing to answer, and that's actually not the refusal coming from the LLM which we're using for the dialects. This is actually the post filtering. It's kind of like post processing of what you asked. So basically, we can check that your request is unsafe. We also can check that your responsive model is unsafe, and we're doing this. But for code generation, I think, honestly, for me, I'm always verifying what is the output of LLM, and I'm always trying to review entire code generated by LLM. There are many reasons for that. Not always it's even security reasons. So one reason actually we can easily understand when I told that base model training takes like 4 months, 5 months, fine-tuning also takes 2-3 weeks. Very often when model actually in production, it's already outdated. Basically, knowledge is outdated. There are new versions of programming language, standard library released. I don't know, other libraries updated too. So model kind of generates code which already is not working, probably. Or using some kind of, techniques which is not working. So this is maybe big reason for me. Second, yes, I'm always trying to check what is the output, because always one of the examples of input for training was a Stack Overflow, And again, memes about the Stack Overflow driven development, they're like going for years. And now this Stack Overflow driven development was brought with LLM like on the scale, You kind of have a coder which can code really a lot, but like quality is questionable. So I would probably validate always what's happening. If you're using by yourself, using LLM by yourself, I would verify always output. If you have some software development lifecycle, probably I would try to build some process around it, Just pass everything through tests and, who maybe have another model which will make tests and run them automatically. But it will be not simple, It's not like you can just let it work.
Here are the other question. Are valid the simple solution of that validation is just for each step of generation of an answer from the model, just send the for each step of pre-generation, generation type, and post-generation, just send the result to another LLM to analyze it?
That's tempting. Again, that's what we're doing on the three-stage validation, but the thing is it's costs. First of all, it's costs. Second, the model which is doing code review also should be trained, and then the thing is if you want to train model for code review, you need to have a lot of code review samples, and that should be very good, high-quality code review. Then if you, for example, have a big company with many developers, you can find actually the way to collect very good code samples, high quality code samples. But let's say if you, for example, a company which is just operating open source data, that's already becoming kind of questionable, because as the quality on the open repositories is not always high, as the reviews is also not always high quality, so that's kind of problem of training set here, yeah? So companies who has a lot of high-skill reviewers, they probably will not give reviews to some kind of, public model. And companies who doing public models, they just cannot get this data because you need to pay a lot. No, I honestly believe even people who actually can do a good review, they will not do review for example, for OpenAI, How much they should pay, for example, to you to sit and review code. I don't believe it's kind of feasible model.
Yeah, it could be a lot of money.
Yeah.
Thank you very much.
Yeah, just a couple. Great talk. The first one actually is going back to the example that you provided feedback or training to got the LLM to produce Boo, for example. That example you passed in, the feedback to get. I'm curious if that was tied to a single account or if you actually tested it. Like for example, if you were to generate multiple accounts, if all of the accounts would have the same impact?
Yes, that's the point of attack. So you actually need many accounts, of course, to guarantee that you will impact the feedback set. And also you need to have, so it also depends how feedback collected. Sometimes we're using some additional tools and software, to collect the feedback. So actually, if you are assessor and you have access to these tools, you have more possibility to influence model. They sometimes let you type in some code. They allow you to, more interactions. It's not just like dislike. But yes, you need a lot of accounts, of course, and you need to use all of them. And the thing is also that, as I said, you don't need to ask like crazy things from model. You can just ask very small, kind of diverge, for example, some small vulnerability, some like a little bit unsafe code in specific situation. It's very difficult to notice even. If someone, for example, reviewing the input of these assessors, people who are making these code samples, or people who are reviewing code samples, it's difficult to notice, that like you even can blame these people. I couldn't understand what this is a SQL injection. I don't know. I think this is a good one, and that's it. It's so easily to kind of impact feedback set. So I think it can become a big challenge, because we really need human feedback. The question is how to get it safely and with high quality. Also feels like very difficult task, to be honest.
Another one, it wasn't covered here in the talk, but I'm just curious if, I use a lot of automated tests, a lot of integration tests, just for non-LLM or non-AI related, just standard development, software development. I'm curious if you've come across or if you actually use any tools to help to create anything special other than ordinary tests for, like either LLM enabled or enhanced type applications.
Oh, you actually can train LLM for everything, You can train LLM for writing tests, for writing front-end code, back-end code.
It's more about not using the LLM for the testing part. It's more along the lines of making sure I get expected feedback or expected results from an application if it is using some form of analysis. For example, if I, say, change models that I'm using from one version of my application to another version, and I want to make sure what I'm doing still works properly. I'm kind of curious if you actually use any tools or services around that.
You can do this. I believe it is possible to do. The problem is that you always have this moment of uncertainty of LLM output. So in a sense, you can try to build a model and train model which will, for example, see that output of your system is not matching with previous version. It's possible to do, but again, you should double check, and well, we always this moment of like trust,
I mean, testing is only about confidence level.
Basically, 100% confident you can be only if you have like handwritten test by some developer, and you know who's responsible for it. So yeah.
Okay, yeah. So we running out of time. So maybe one last question, just in case, like anyone has it. But yep. Yeah. Thank you, Yury.
Okay.
Yeah. Thanks.
Thank you.